the Wi-Fi, you should connect to the Algolia guest, and the password is real time. If you are tweeting, don't forget to add hashtag Algolia search party. So thank you for coming. So we are doing it. It's a recurrent event that happens around every 2 months. Just to know, like a quick survey by raising a hand. How many of you did already come to Algolia search party? Okay, so let's say a third. Thank you very much. And who knows already what Algolia is? Cool, that's way much. So for those who don't know, Algolia is a hosted search API that gives developers the complete toolkit to build search within their project. We are a SaaS tool that takes the pain out of building search. We maintain the infrastructure and API clients for most important API programming languages and also platforms. We really focus on developer experience by providing excessive documentation and also some support and some tooling for that. So tonight we will speak about Kubernetes. We will welcome our three super cool speakers. So Pierre-Gilles Mialon, that was working at Radio France. He is now working at BlaBlaCar, and he will speak about what is the Kubernetes disruption. Then Arnaud Legon will introduce you how to modernize your infrastructure thanks to Google Kubernetes engine. And finally, we will have RCS, it's his nickname, that will introduce you how to not use Kubernetes by killing the Algolia dashboard. So please give a warm round of applause for our first speakers, Pierre-Gilles.
Good evening. I'm Pierre-Gilles Mialon, and I'm here to share what the most important disruption came with Kubernetes. Nearly 20 years ago, I started working for the web industry as sysnet admin. At those times, sysnet admin was a nice word. It meant you rocked both the network and the system, or at least tried to. Now I prefer web architect or cloud experts. First, I was as head of hosting at NetActive. Linagora bought NetActive in 2008, and I became the head of hosting for Linagora Group. I left my 400 beloved customers to retire with a single final customers, Yakaz, and Hatch search engine. In 2014, Google decided that vertical search engines weren't useful anymore, so it reduced traffic to 1/4. Then I helped Radio France to migrate their web service from bare metal to VM, and then from VM to Kubernetes. Now I help BlaBlaCar in their cloud migration. Okay, it's your turn to introduce yourself. Because of time, I propose to ask you a few questions. Please raise your hand if your answer is yes. First, who knows what a Kubernetes pod is? Okay, for the few that didn't raise a hand, a pod is a group of one or more containers with shared storage and network, and a specification for how to run the container. Who knows what a Kubernetes deployment is? Okay, a deployment declares the state of a set of pods running a stateless workload. Who knows what an headless service is? A standard Kubernetes service creates an IP and will load balance the traffic on pods. Sometimes you don't want or you need to access directly to the pod without the IP, so you can create an headless service that will expose direct IP. Who knows what the Kubernetes endpoint is? But endpoints are a real target of service for Kubernetes. They are updated whenever a set of pods change. But in some rare use case, you want to address through services that don't have pods. For example, you want to have a service in Kubernetes that have to reach external endpoint of your Kubernetes cluster. So in this case, you declare the IPs directly into the Kubernetes endpoints. Who knows what a pod disruption budget is? Okay, I will introduce this subject later in my presentation. To finish, are you a smart-looking dev? Who are smart-looking dev? No developers? Okay. Who are an ugly ops? Yes. Who are undefined DevOps? Who didn't raise their hand? Where are you there today? Let's start with cool people. Is Kubernetes cool for developers? Yes, it is. But why? Because everybody says so. For those who are using Kubernetes, is it cool? Yeah, very cool. So yes, first reason Kubernetes is cool because cool users of Kubernetes think it's cool. Second reason, Docker is so cool. But why? Docker will ship your code as a dependency as an artifact. You can keep track of version. It's easy to share. You just have to give the image, the address of the image with the right version to your teammates. It's great for portability. You can work on Mac, on Linux, even on Windows. It will behave the same as in your production environment. It grants isolation. So cool. With Docker, you can set up proof of concept in a minute and validate them in production 2 seconds later. I'm joking. But since you are using containers that start in few seconds, your deployment in production will be faster than in a VM-based cloud. With Kubernetes, your workloads are defined as code. So it gives you the ability to replicate, to iterate faster, to define advanced continuous deployment workflows. Kubernetes provides a unique interface with its API for logs, metrics, alerts, so you have the power. Kubernetes defines fine-grained permission with RBAC, role-based access control. With those permissions, each of you can access only what they need. They are not lost in the wild. As I said earlier, your workloads are defined as code, so you can copy-paste almost everything. I think I didn't need to teach that to the generation that uses Wikipedia to do their homework. Yes, you can duplicate. And in case of trouble, before sending a Slack message to your infrastructure team, perhaps read your application logs. Kubernetes will give you the ownership of your services. Since they have simple access to their workload, to the observability stack, they are in position to operate their code in production and to be on call. So developers, teams can iterate faster without slow interaction with other teams. Less frustration, more ownership, more speed, more pleasure. You build it, you run it, and hopefully it will be the end of the ops problem. Okay, Kubernetes seems pretty cool for developers. Is it cool for their friends ops too? Once again, everybody says so. Because Kubernetes provides a great network abstraction with features like load balancing, service discovery, network isolation, network security with fine-grained permission. Kubernetes also provides the auto-scaling features that permit to adapt the resource allocation to the traffic within few seconds. The provisioning and the resource attribution that is tedious work with microservices architecture disappear. Better resource allocation with more efficiency will result to reduce costs. To finish, Kubernetes provides a great way to deal with storage. It became easy to attach disks and containers at scale. Cool. Kubernetes is cool for developers, is cool for ops. It seems there's a kind of magic in it. So is it the land of ponies, the place where developers and operators can share mojito in a swimming pool together? Let us be serious for a moment. Imagine your code is a really smart-looking rabbit. As always, your code is perfect. Your code is peaceful because it is flower-powered, but put into production, and it will be lost behind the code of the other team. Kubernetes is not smart by itself. It does what you ask for, no more, no less. If you define nothing to protect your rabbit, the issue will be fatal. Your rabbit will be killed, and it didn't deserve it. I know I should have a warning for the sensitive soul, but sometimes the life is cruel. Now you have a question. Who is a nasty guy who kills a kind rabbit? Is this guy Kubernetes? Is this guy a member of the infrastructure team, the one who never talk, only to blame? Not really. This can be a human error. Cluster administrator deletes the VM by mistake, shoot. This can be a cluster operation, draining a node for repair, upgrade, or fix a security issue, draining a node for scaling up or down. So cluster operations are killing rabbits, and sadly, everybody have to deal with that. Other reasons of death are a hardware failure, a failure of the cloud provider, a kernel panic, a network partition of the cluster. The rabbit can be killed due to a node being out of resources. So a Kubernetes cluster is a disruption by design. You have to deal with. If you want peace, prepare for war. But our rabbit can be secured in a not so cool place like a Kubernetes cluster. First, you have to choose the right type of objects. Please never use low-level objects directly, like pods or replica sets. The big picture is the following. Deployments are for stateless services, workers, website front. Stateful sets are commonly used for stateful services like database, buses, replicated storage. Cron jobs are for cron, when you want to schedule a repetitive task. Behind the deployment host, the stateful set, you want to expose a service. This will be the only entry for other workload to find the pod of your deployments. When your pod is launched, you have to check its status. Two types of check exists. The liveness. If it fails, the container will be restarted. The readiness. If it fails, the pod becomes not ready, and the service stops sending traffic to this pod. The liveness here is here to deal with when in doubt, reboot. For the readiness, it could be different. Sometimes application can have temporary spikes. In those cases, stop traffic will permit to recover faster while the cluster is scaling. You should define requests for both CPU and RAM. The requests for both CPU and RAM are only used during the scheduling of your pod. Kubernetes will search a node that fits the amount of CPU and RAM you declare as a request. Try to declare a value that represents the high common use for your containers. You will have to iterate to find the correct value for most of your workload. Observe and adapt. This is the right way to do. For the limits, the behavior is completely different for RAM and CPU. If your container reaches the limit of RAM, it will be killed immediately. If your container uses a memory capacity bigger than the request, but less than the limits, and the node is under memory pressure, your pod could be killed. For the CPU limits, things are different. Your pod will never be killed because of CPU usage. But if you approach the limits, your process will be throttled. The throttling is like something really, really, really slow. My advice is to use CPU limit as a protection against fork bump-like process. You can set it very, very high just to ensure that a process that didn't behave the right thing, don't block other process on the host. To sum up, penalty for RAM overuse is death. Penalty for CPU overuse is slowness. Now, if you want to have a snap, it's the right moment, the most boring slide ever. You know that sometimes pod dies for the good reason, like a security fix. But when Kubernetes kill pod, it can be nice. First, we start a pod. Optionally, launch init containers. They can do work like fixing permission on a file system before the container starts. Kubernetes will wait until the init container exits before starting containers. If you have multiple containers, they will be launched together. If you have a race condition between container start, you have to deal with it in the container entry point. Optionally, Kubernetes can launch post-start script. There is no guarantee that they are launched after or before the container entry point. Now the container run, everything is okay, but you want or Kubernetes need to stop the pod. The order to stop is launch in Kubernetes. The container is immediately set as terminating is stop receiving new traffic. For example, your container is Nginx. Kubernetes will send a seek term to Nginx. Nginx will operate a quick exit. This is the normal behavior of Nginx when it took a seek term. That means it will drop all connection immediately. If the process doesn't exit in 30 seconds by default, Nginx will receive a seek kill, and this is the end of the story. But optionally, if you declare a pre-stop script, you can send Nginx squit before Kubernetes sends seek term. In this case, Nginx will finish the connection and exit at the end, and this way you will be kind and exit gracefully. You have to define rolling update strategy. You have two parameters you can deal with. They could be integer or persons. Max and available, which define how many pods you accept to lose during the upgrade. Max surge, that will define the number of pods that the scheduler will launch at once. And all pod will be replaced only if the new pod is alive and ready. As I said earlier, there is no magic in Kubernetes scheduler. For this reason, you want to have affinity and anti-affinity. For example, you have deployment that runs on 3 pods. You want to add a node repulsion between those pods. Eventually, if you are running on a multi-zone Kubernetes cluster, you want to add zone repulsion too, to ensure that pod will not be scheduled on the same host or the same region. Sometimes you want to collocate on the same node deployments that will call each other frequently. Affinity is the right tool for that. There are 2 ways to define affinity and anti-affinity, preferred or requested. My advice, preferred is often the best choice. Requested can start new node or block the schedule of your pod, for example, during scaling of the deployment. One of the most interesting features of Kubernetes is its ability to scale. When you create a deployment, create the associated horizontal pod autoscaler, or HPA. Kubernetes lets you scale on CPU, RAM, or custom metrics. Imagine you can scale your workers with the number of messages in a bus queue. It's beautiful. You can scale your Nginx on the number of connection or requests, or both. So during the scale-up, if you declare a requested anti-affinity on zone and you already have a pod in every zone, then the deployment will never scale up. Last but not least, the pod disruption budget. A PDB limits the number of pods of a replicated application that are done simultaneously from voluntary disruption. For example, a quorum-based application would like to ensure the number of replica is never brought below the number needed for a quorum. A web frontend might want to ensure that the number of replica serving load never fails below a certain percentage of the total. Still, you have to be aware that a bad setup on PDB can stop a cluster update. Thank you for your attention.
Thank you very much, Pierre-Gilles. If you have any question, feel free to raise your hand and we will send you the catch box. Yes.
What would be the...
Can you speak in the mic, please? Oh.
Ah.
Technology.
What do you think would be the best size for a team to use Kubernetes? From which size does it becomes interesting for a team?
Any size, I think.
Okay.
It's really nice. I host websites for 20 years, and it's the greatest thing that ever happened. I spend time racking disk in servers with this kind of things. It's never happened again.
Thanks. We can do still 2 more questions. Anyone?
Hello. I have a question that you might have come across. How would you propose to manage the shutdown, a graceful shutdown of a pod with a container and a sidecar, where you want the sidecar to end after the main container is shut down? For instance, I have a sidecar that's shipping logs.
You share a volume, and you put and you write a
PID file.
A lock, and you ensure on both container you ensure that the lock has disappeared before shutting down the second one. So you with a pre-stop script. At the beginning, when you start your containers, you create the lock, and after. Before killing, you have the containers that should die the first. Mm-hmm. This one remove the lock, and the other one will never stop if the lock still exists.
Okay.
I'm really new to Kubernetes, so it was just like having a newbie definition of what is Kubernetes, and in my understanding, it's like used to help web-based application run smoothly and optimize the cloud resource consumption, something like this.
Yes. It's not only for web-based application. You can do everything with Kubernetes. The object of Kubernetes is running containers at scale. It's a way to. 20 years ago, we were trying to launch process and to ensure that the process were running. Kubernetes continue to do exactly the same thing, but with other tools, and we can. Now we can leverage a lot of issue with the hardware stability. The idea is you can increase your reliability because you have a lot of servers. You can have multiple dredging, and you didn't see your process like something on a single host that run just in parts that can be cut.
Yeah. There's 2 things I understood. One is it helped developers to push to production and version their codes. And the second one is really the load balancing and cloud resource optimization. So it makes both.
Yes, it makes both.
Okay, sorry, very newbie question. I'm sorry, but
you will have time to ask questions afterward if you need. Thank you very much, Pierre-Gilles. A big round of applause, please.
Merci.
Now we will have Arnaud from Google that will introduce us how to modernize our infrastructure thanks to GKIE.
Thank you very much. Hi, everyone. Can you hear me well? Hi, my name is Arnaud Legon. I worked at Google Cloud France as a customer engineer. So my role is kind of a cloud architect for tech companies, including startups. So for example, I'm helping Algolia in their deployment to the cloud regarding GKE. So for the people that are new to Kubernetes, you're going to have more insight about why it's useful, where it's coming from, and as well what's kind of the trend with Kubernetes and why it's kind of so cool. So I think it's going to be great on that point of view, and how Google is providing you the best tool, meaning GKE, Google Kubernetes Engine, in order to host your Kubernetes environment. So most added value of Google for a lot of people is all the different applications that you can access. So for example, Maps, Gmail, YouTube. But the real key value of current Google deployment is the infrastructure underlying Google. So right now, it's kind of more than decades of deployment regarding the infrastructure and all the learning that we've done internally in order to scale from a few servers to the biggest infrastructure on Earth. Right now at Google, everything is about containers. You're going to see after. There has been more than a decade that we have kind of initiate the concept of Linux containers and how we are processing them at scale. Everything runs in a container at Google. So your Gmail inbox, when you're going to go to Maps, everything is going to be in a container. Even virtual machines. So for the ones that are going to GCP, Google Cloud Platform, and running virtual machines on the cloud, at Google Cloud Platform, your virtual machine is inside the container itself. And it's about 4 billion containers per week. That's kind of the fun fact regarding how big is it. So when we look at the timeline in a few words, so it started all in 2006 when our infrastructure started to grow rapidly. And we decided to kind of expose best practices in terms of framework, but as well in terms of best practices in order to manage better containers at scale. So we've pushed Kubernetes, as that has been unveiled in 2014. The V1 has been published actually in July 2015. And GKE, so the managed version of Kubernetes, has been published 1 month after. So it's already Kubernetes almost 4 years old now, and our managed version almost 5 years as well, 4 years as well. For the ones that are not familiar with what is a container, just in a few words. So people used to deal with bare metal servers. So basically, you host your server, you have full access to it. Then we move to virtual machines, and now people are moving to containers. So you're just packaging your application with your dependencies, and it kind of be able to be spawned kind of everywhere in an environment. So that's kind of the idea of adding abstraction regarding the physical machines that will serve your application. What is Kubernetes? I've already kind of answered the question, but just to let you know, the key point of Kubernetes is just that it's not only an open source project, it's that it's part of the CNCF, so the Cloud Native Computing Foundation, meaning that it's supported by the entire industry, not only by Google, so by Twitter, over tech companies, Red Hat as well. And those companies are as well contributing to the project. So you have the community and a set of different companies going to Kubernetes. That's why a lot of workloads are going to Kubernetes. And Kubernetes is, by the way, the first project regarding engagement on GitHub. So the big question that someone asked, why are people really excited about Kubernetes? So in a few words, it allows you to merge all your running applications from an operations perspective. So if you're an apps, you're going to manage a cluster. You won't care about the underlying infrastructure. So that's kind of a pretty cool thing. So your cluster will run different applications from all your different teams, developer teams in your company. One thing that is often associated to Kubernetes is that it's scalability. So we're going to cover that later in the presentation, how we're going to help you to scale your application and serve your customer without any downtime, and to make sure that you're able to scale the demand. And as well, from an ops perspective, you're going to have a better control of your deployments and the versioning of your application. You're going to be able to easily update your application seamlessly. The key thing, two things that are really important. So it's the things that Pierre-Gilles mentioned as well. The first thing is Kubernetes is an abstraction of your infrastructure. And we're going to see that after. you won't care about your machine at all with Kubernetes. And the second thing is that Kubernetes offers a declarative set of APIs to orchestrate your containers. So it's going to be easier from an ops perspective to manage all your deployment at scale without having to scale your ops team. So that's kind of the key factor of Kubernetes. For the ones that have done containers in the past with Docker or other platform, you have to handle a lot of things when it comes to manage containers at scale for your different applications, and it can get very complicated. So from that point of view, from that perspective, Kubernetes is a toolbox that allows you to manage a lot of things. And the key differentiator between other container orchestrator is that Kubernetes has been done in an opinionated way, meaning that with the best practices that we've done at Google during the last decade about managing containers, we've made some choices that we have implemented into the development of Kubernetes. So Kubernetes offers you all the toolbox of those different features, and after we're going to see how is it easier with Kubernetes engine. But getting started can be a good challenge. I'm not sure how many people in the audience created a cluster. Raise your hand. Okay. Is it easy? Okay, thank you. So it's not that easy, despite a lot of people saying that Kubernetes is an easy way for managing things. That's an extract of the GitHub by Kelsey Hightower, who works at Google actually as a developer advocate for Kubernetes, for GKE. So it just, on this repo, you have all the different steps in order to have a minimum viable cluster working in not even of production, but at least a working cluster. And it takes a lot of things and a lot of steps. And that's just the beginning, because as soon as you have a cluster, you have to manage it. And that's as well where the all tricky stuff is going. So you have to make sure that it's secure. You have to make sure that you have to set up high availability of your application, as well patch when there is a security update. So it's quite still a lot of operations to do. So with that, we have a solution. That's a bit marketing pushy, but the solution is Google Kubernetes Engine. That is the ideal way of managing Kubernetes. And when we look at, as well, the quotation from Kelsey Hightower as well, back in 2015, back in time it was Container Engine and not Kubernetes Engine, he says that it's a cheat code for managing Kubernetes because a lot of things that are quite time-consuming, let's say, are going to be taken care by Google from that point of view, and literally by Google people. So we're going to check that. I mentioned it. I mentioned that Kubernetes has been launched V1 July 2015, a month after our managed version of Kubernetes has been set up. So the key thing and the key differentiator compared to the industry is that we have 4 years of experience, not only running our own infrastructure, but as well running different customers' infrastructure. So when we look at public, for example, references of people hosting Kubernetes environment at Google Cloud Platform, it's a lot. So for example, Waze, which is now part of Google, the Meetup website. In the French ecosystem, we have Captain, previously Chauffeur Privé, for the ones that knows. King as well. So King is a developer of Candy Crush, the game. Pokemon Go as well, that has been fully deployed on Kubernetes Engine. So the promise is to have a cluster running in a single click. So you won't have to first select your machine, select your storage, define your network topology, all of that. You're just going to do one click and you're going to have your cluster. But what is exactly a Kubernetes cluster? Because we've talked a lot about nodes, pods, but what is exactly a Kubernetes cluster for the ones that are pretty new to that? So that's a cluster. Basically, you have a master and you have different nodes. Nodes are virtual machines that will run your application. In each node, you have a pod, and you're going to have a master that will manage all your cluster, your entire cluster. So we're going to deep dive into the master. When you go with Kubernetes Engine, we're going to take care of it. You won't even see it. You won't even have to manage it. You won't even have to upgrade it. It's going to be taken care of by Google. And when I say it's going to be taken care by Google, it means that it's actually the same SRE team that is working for having 24/7 all Google services running that will take care of your master running. So you won't see them, they won't be in your console, but it's going to be taken care by us. And it's free of charge, so you're not paying for them. So that's kind of as well a good benefit compared to managing your own infrastructure. So you're going to have more ops, and you're going to pay for the machine serving your cluster. So that's kind of the main benefit. Then you have nodes. Nodes, I said, it's virtual machines that will host your different pods that will run your application. And we have what we say node pools. When you're going to manage a cluster, you're going to have different applications running on top of it. You're going to have applications from your data science teams that will need GPU acceleration for machine learning learnings. So with GPU attached, you're going to need nodes with a large amount of CPU and memory. So you're going to be able, in Kubernetes and in GKE, to define node pools, so different type of machines that will host your application. So that's kind of a feature of it. Now I'm going to talk about how easy it is to set up your cluster, and as well how your cluster is going to scale. So that's one thing as well that Pierre-Gilles mentioned. He covered regarding the horizontal pod autoscaler. So we're going to deep dive about the 4 different types of scaling your application on Kubernetes. First, we're going to go to the node auto repair. So when we can see that one node is, for example, not responsive, returning a not ready status, we know that, okay, something is wrong with that node. So what we're going to do, we're going to drain the pods in that node, and we're going to spawn a new pod to your new node to your cluster. So that's as well a basic feature that comes with GKE. So you won't have to do it by yourself and check the real status of your nodes. It's going to be managed by the infrastructure. And that, like all the different features that I'm mentioning, is not for kind of being marketing savvy. It's really because that's the differentiator that have made companies deciding moving to GKE instead of running their own Kubernetes cluster. Second thing is about auto upgrade. I'm not sure like if people did an upgrade of a Kubernetes cluster in the audience, but it can be quite difficult for a couple of reasons. And often it ends up with the cluster being killed and set up a new one with a different version of Kubernetes. That's kind of the reality of a lot of companies. With GKE, it's going to be done seamlessly. You won't see any downtime. We're going to see that later on, but you won't see any downtime, and your master will be upgraded seamlessly. But the key thing is about security updates. So the same way that for the upgrades, for all security patches, you're going to receive them directly without any downtime of your application. So that's kind of the good benefits. And that's why it saves a lot of time for your ops team to move with a managed version of Kubernetes with GKE to not have to do this. So for example, if we look at the recent RunC security vulnerability that happened 2 weeks ago, so everything was patched for customers directly. So that's kind of a key feature. Now we're going to talk about scaling, and after we're going to talk about high availability as well, how you can provide a global application serving all your different customers. But first, your application, before being available globally, it has to scale to the demand. So first, scaling your workloads. So let's look at what Pierre-Gilles mentioned. So you are serving a web application, and you have a lot of customer requesting to access. So based on different metrics, CPU, memory, or even custom metrics, you're going to be able to, Kubernetes will be able, GKE will be able to directly scale new pods of your application in order to manage the different metrics under the throttle of scaling your application. So basically, you are going to deploy more of your application within the defined cluster. So that's kind of the horizontal pod autoscaler, so the HPA. Then we have what we call the vertical pod autoscaler. One thing as well that Pierre-Gilles mentioned, it's sometimes very hard for ops and for developers to know exactly what's going to be the memory and CPU consumption of your application. So you're going to work on a microservice, but how much memory does it need? How much CPU does it need? It's really hard to know, and you're just going to try. It fails, try again, but it's not very fine-tuning. So with the vertical pod autoscaler, Kubernetes will check kind of the behavior of your pod, and we're going to adapt the size of the pod based on the requirement of your application. So that's as well a feature that helps you to size the right way your applications in your cluster. So the two first autoscaler were about scaling your application itself. Now we're going to see that scaling your infrastructure. Because in the two previous scenarios, we were on the same amount of machines. So you set up a cluster with 5 machines. We're going to try to fill those 5 machines. But what happens if we need to schedule another pod, but it's running out of space? So that's where it comes from, the cluster autoscaler. So basic feature. The master will not be able to schedule a new pod in your existing environment. We're going to schedule a new node for serving your application. Adding a new node takes only 2 to 3 minutes on GKE, Google Kubernetes Engine. For people that are dealing with managed service of Kubernetes or anything like this, it's 10 times more. So the time to provision new nodes. So Kubernetes GKE is really good in that way for scaling your application in very short amount of time. And another feature about the type of nodes that will serve your application is about what we call the node auto-provisioning. So that's a new feature that, based on the different workloads, we're going to recommend new type of machines that will serve and host your pods. So for example, okay, we think you need bigger machine, or you think you need this type of machine that will be better and more efficient in order to scale your application. For example, if we see that you have a cluster and a lot of free space, okay, maybe we can just add another type of machines that will be smaller in your node pool, and we'll use those type of machines in order to scale your application. So those were the 4 different types of scaling your application: 2 for the pods, 2 for the nodes. Now, how we're going to build highly available application. Now that your application is able to scale, how to make sure that everyone can access it globally. So at scale, how you're going to deploy your application. First, you can have what we call the multi-zonal cluster. So for the ones that are just explanation, in the public cloud, you have region that is a group of data center, and inside each region you have a few zones that are fully autonomous regarding energy, disaster recovery, blah, blah, blah. So the idea here is about building and splitting your different workloads into each zone of your region in order to mitigate the risk of having an outage in one zone. So you can just enable the feature, and you're going to have your pods being deployed into different zones in order to have a balance and not having one single point of failure for your application. And the same for the nodes, the same for the masters. So we have what we call regional cluster on GKE. So basically, you're going to have 3 masters into 3 zones, so 1 master per zone. Each master, of course, will scale up based on the demand. As well, so it allows you to have 0 downtime upgrade, because we're going to upgrade 1 master. The 2 other will serve the entire application, and we're going to do a rolling update like this. And it allows you to have 99.95 SLA for the service. So that's really key for deploying high availability application. And as well, it's free of charge. So if you have one master or 3 master, it's the same price, 0. So if you are deploying any application, we strongly advise you to use regional cluster. It will facilitate all the different master upgrade in your Kubernetes environment. And then, once you're going to go global, you're going to need to have what we call the multi-cluster ingress. So for example, you have people Pokemon Go style. Okay, a lot of people are connecting to the platform. You want them to go to the nearest location of the cluster that will serve their application instead of doing the entire world for each call of the service. So that would be stupid. So your user will directly go to the global load balancer, and after we're going to split the traffic to the nearest location for your customers. So that as well allows you to have a highly available application, reducing latency and better customer experience for your end users. I'm not going to go into details into that part, but we're offering you a lot of benefits from moving to hosting Kubernetes on GCP. The key thing was, the message I deep dive was about scalability, availability of your application. And if you want to do that on Kubernetes, it's fine. It's going to be complicated. If you go on GKE, it's going to be much more easier. So to wrap up, Kubernetes is definitely as adopted by large companies, startups, and also the entire industry. So for example, Red Hat, IBM as well. So it's definitely kind of the future of orchestrating and deploying application. So in one sentence, we can say that Kubernetes is on fire. And we're going to be here, actually, we are a few people from Google Cloud France in the audience to answer any question if you have or to discuss. So I hope it kind of allows you, for people that are quite new to that, what is Kubernetes in a better way, what is a cluster, and also for the ones that are having issues with their own Kubernetes cluster, maybe moving to GKE, that will be easier. Thank you very much.
Thank you, Arnaud. Sam, we have time for 2 or 3 questions. Anyone?
Yes, can you talk to us a bit about the Google hybrid cloud and when you plan on offering it to people here in Paris?
So the first answer will be, good question. Hybrid cloud, so back in July last year at the Next 18 conference, Google unveiled what is called GKE on-prem. So basically, you're going to be able to deploy and to manage Kubernetes cluster that will be in your existing data center, but the master will be on Google Cloud Platform, and you're going to have all the benefits that I mentioned, but your workloads being deployed locally instead of in the cloud. So that's kind of the explanation of what is a hybrid environment for GCP, for GKE. The status right now, more news in 4 weeks. In 4 weeks, we're going to have the new event Next 19 that will be in San Francisco, and a lot of announcements will be made. Actually, the service GKE on-prem has been released as beta 2 weeks ago. So a few companies you have a lot of criteria in order and requirements in order to deploy it, but at least it's a beta as of now. But the strategy regarding that will be unveiled in 4 weeks from now. So yeah, strongly advise you to watch the live stream.
Thanks. Any other question in the audience?
A question over there.
That's okay.
Please take it up.
Oh.
This way.
Thanks a lot. Do you know if big cloud platforms like Salesforce, ServiceNow use these technology or are running on their own?
Regarding public, so I'm just going to talk about public customer references that we can explain. Yeah. So far, we can see large deployment of Kubernetes. Regarding those particular companies, I cannot disclose anything. But yes, the answer is yes. Large companies running like big industry in the web industry, big companies, are going forward with Kubernetes and are going forward with GKE especially.
So you just cannot say who is running on Kubernetes, but they do.
I can just mention the public references, but we have way more bigger deployment.
They don't reinvent the wheel.
No, actually, on Kubernetes, a lot of companies are adopting that first because Kubernetes is, I haven't mentioned, but Kubernetes is a rewriting of what we have internally at Google, which is Borg, that is managing our entire platform. So Kubernetes is another way of doing that in another way. But yeah, companies decide to move to Kubernetes and as well, especially to GKE. So. Why? Could you explain why? Well, why? Because it's easier. The short answer is easier. The long answer is they've tried to do their own way, and at a point when it times to scale, it's kind of complicated. So I cannot say more names, but it's that way.
And it's not their core business.
Exactly as well. But even tech companies that are it's their core business to develop their own application are moving towards Kubernetes in that way as well. So.
Thank you very much. Sorry. We will have time later.
We can follow up after. Thank you.
So now you will have a presentation of RCS working here at Algolia. Go ahead.
Hello everyone. So today I will speak to you about how not to use Kubernetes. There is a very special day every year which is called the Black Friday, where internet goes on sales. And at Algolia we are powering a lot of e-commerce platform, and so our number of requests are like completely skyrocketing. If you are working in the e-commerce business, you probably heard of this day, and you know that it's a very, very special day. A lot of things can happen because the number of requests and number of users to our website are completely going crazy. And on last year, we had an outage of around 45 minutes on the Algolia dashboard. So it's the connected part of the www.algolia.com. So what happened? On this nice graph, it's a new relic. You can see during the outage what exactly was happening. In fact, all the requests were taking up to 60 seconds, so they were eating a lot of timeouts. And most of it was due to a request in MySQL. But where was it coming from? Was it the dashboard? As it's Black Friday, you know, we expected a lot of customers to use the dashboard. No. In fact, it was coming from another service calling an internal API of our dashboard. And that was this one. So this is an internal endpoint. What it does is not very important, but basically here what we see, it's a classical example of cascading failure. We have another system that was overloaded because, you know, Black Friday, that managed to kill our dashboard. So what happened exactly? In fact, we had one external service, a new one that was in beta at the time, that was like bombarding our dashboard. Instead of doing one call every 5 minutes, it was doing multiple calls every second. But how do you do that? So basically, you have a cron job that runs every 5 minutes, so a task running every 5 minutes that was doing one API call. So how do you transform a cron job from 5 minutes into a DDoS system? So that's what I'm going to present you. I'm Rémi Christophe, I'm working at Algolia, and I will present you how to transform a cron job into a DDoS system. So you will see it's a very, very complex thing. So first, you use Kubernetes. Thank you. I'm joking. So first, before to understand how we managed to do that, let's talk about the architecture of one of our new products, which is called personalization. Basically, personalization is 3 different services. The first, it's called the Insight API, where we receive user events. Then in the middle, we've got the personalization engine that takes those user events, processes them, and then transfers them to the search API. So every time you search on our search API, you've got personalized search. So let's deep dive a bit. So on the central part, so the perso engine, we have basically 2 things. We have a queue where we have things to build, jobs to build, and workers that take one job from the queue and build something and send it back to the API. And you know, we are running on Kubernetes, we like Kubernetes, and we are like, okay, so basically we are running tasks in a worker. But the job of Kubernetes is to run jobs, pun intended. And so maybe we could leverage Kubernetes to run those tasks directly inside Kubernetes. Instead of relying on workers, we could say, okay, Kubernetes, here a job, schedule it, do something, restart if it fails, and maybe it will work. As we are in beta, it was kind of okay. We are trying new architecture and new way of doing things. So basically what we did was very simple. Instead to have a worker that was taking the task from the job queue, we had, like we call a builder that was taking a job, asking the Kubernetes API, please schedule this job somewhere, and it was running smoothly. Kubernetes was doing its job, running jobs. Obviously, we didn't try to change it the first day. We tried both of it in parallel for a few days to see how it works. And in fact, we were very happy because the full pipeline was working pretty well. We were using Kubernetes way better in terms of resources than with the worker pattern. And so we said, okay, let's continue with architecture and delete the old one and just use this new one. Cool, it was working. Just to give you a bit of idea, for 1,000 user events we receive, it resulted in one task, so one job in Kubernetes. just to give you a rough idea. And one morning, we arrived at work and we received this nice email. Dear Algolia, we would like to send 160 million user event in a few minutes the day before Black Friday from our dear anonymous client. Obviously, this didn't happen, but we didn't receive the email, but we did receive the 160 million user events in around 10-20 minutes. You remember the one task equal 1,000 user event? Me too. This command basically is able to get us the number of jobs currently running in Kubernetes. So at one point, we had like 150,000 jobs running in parallel in Kubernetes. So that was okay. So before trying to understand how it could happen and how we managed to get to this point, let's go a bit into how Kubernetes works. You had two good presentations before, so I won't go into much details. But basically, you've got the Kubernetes master, the nodes where your code is running. Inside the master, you've got the API server, the scheduler, the controller, etcd. But the thing is interesting here is that we are on GKE. So in fact, as I said before, the masters are managed by Google. We are happy to let them manage them. But the thing is that they are a black box. We don't know what's happening inside, and we don't want to know what's happening inside. But the thing we are like, okay, we have a cluster that is doing weird things. It's doing like with the cron job DDoSing our dashboard. So what could we do? What's happening? So let's try to understand what was happening inside our cluster. No. So this command basically is able to give you the resource usage of all the nodes of your cluster. And as you can see, basically, Kubernetes will say, no, I don't know, I won't answer you. You might expect this was extremely very not good. So how could it happen? Our hypothesis, because that's only hypothesis, we never could understand what really happened inside Kubernetes. What's that? Is that in the horizontal, you've got the time, and in vertical, you've got the jobs that are currently running inside Kubernetes. So at the beginning, you have some jobs running. It worked. Then at T+1, we had one job that finished, and then we are more job unqueued, and so on, and so on. And then basically, all the cron jobs were scheduled exactly at the same time. And that's how you transform a 5-minute cron job into a cron job running every second, basically. Because in fact, it happened for a lot of days, and all the scheduling of the crons were launched at the same time. So instead of running one cron every 5 minutes, we have the same cron running every second. So how could this happen? We make some bad assumptions. The first one is an easy one, is that starting a job in Kubernetes is fast. What we measured was the time from an event coming inside our pipeline to the time it goes out. And in fact, in average, it worked pretty well, and it was the same time as with the normal worker pattern. But the thing that we forgot was to measure on each and individual step. And what happened is that our jobs were taking around 100 milliseconds to run, so the actual code. But in fact, the init of the job, the close of the pod, and so on, was taking more than 5 seconds. So we had like a huge overhead where we had a CPU running just to start our job instead of doing the actual work that we wanted. The second is that we could process jobs faster than the incoming events. In all our tests, it was the case. So in fact, it worked very well. We had a lot of jobs running in parallel in Kubernetes, like 100, but as they were killed and start at the regular pace, so it was working. Here, as we had a huge spike of number of jobs running, we had too many at the same time, and Kubernetes was like, eh. Lastly, customer warn you before using a beta feature a lot. Thanks, customer. If you have to remember one thing from this presentation, would be this, so please listen carefully, then we'll have food, don't worry. I think that's a very nice way to see how you can see the limits of a system. So just let's see that. In horizontal axis, you have the number of indices. So it's a system that could have indices, and it has a limit, because all systems have limits. In the vertical, you have the number of objects with a certain limit. And where is the real actual limit of your system? So you can probably think that it's the sum of both limits. Probably not. Most of the time, the systems are designed to work either very well with a lot of, for example, indices in this case, or number of objects, but not both. The limit is probably not on this line either, because as I said, the system was not tested in average, but in the maximum on each feature and not on the average of all feature. And the real actual limit of your system was probably more on this nice curve. So when you have two features to see the limit of your system, it's easy. You can graph it, I can display it on a TV. But when you have 100 million features like Kubernetes, seeing the real limit of the system is very hard. And that we did. We know that you can run a lot of things in Kubernetes in parallel, but you cannot start a lot of things at the same time. And that was one of our bad assumptions. Some last takeaways. First, ask feedback from your providers. In this case, we got our phone, we asked Google, hey, can you help us? And they were very quick to come, and they explained a lot of things. They know Kubernetes more than we can do, that we can know. And so when you have a system that is maintained by someone else, ask them. They will probably know better than you. The second is always put limits. Our system, our design could work, but we forgot to put limits. And that's how we managed to schedule hundreds of thousands of jobs. If we had put like some rate limits or some limits on the number of jobs we started at the same time, it would have handled the load and it could have probably perfectly worked. Another, always test your assumptions. As I said, we made an assumption on the start time of the job, of the capacity of Kubernetes to handle both its limits at the same time. It was assumption and it failed badly. And the last, A/B test and load test, easy. As I mentioned, we A/B test architecture. I think that was a very good decision, but we didn't go far enough into this A/B test because we measured the full thing, but not all the small steps, and that was what was the issue in our case. And lastly, please use Kubernetes, but properly. Thank you.
Any question?
You're hungry?
The question was, A/B test is unit testing?
It could be here. It's A/B testing. Your full in our case, it was a full architecture, but you can do at the scale you want. It's just to have an idea of running two things in parallel and see how each thing is behaving correctly or not.
How did you fix the issue? Just waiting?
We destroyed the cluster and we created a new one.
Eventually, how did you manage the queue issues and the limits on this problem?
We went back to the previous architecture with a simple queue and multiple workers.
All right. No more question? Cool. So food and drinks now.
Thank you.
Thank you very much, RCS. Just to let you know that you will receive an email in the few days letting you offer any topics you would like to see happening in our Algolia search party, or if you want to be a speaker, so feel free to reply. And we are organizing a tech lunch on next Tuesday about mentoring, so feel free to join. It's at noon. It's on Wednesday, sorry, Wednesday. Thank you very much.